Hello students, I'm Mohammed Abbas Malik, Assistant Professor, Department of Electronics and Communication. Today we will start Unit 4 of Random Process and Information Theory. Unit 4 basically deals with correlation function and power spectral density. So starting with correlation function. Correlation function, it just relates two processes or two variables. They are related to each other. How? Or you can say you try to find the relation between two random processes or two random variables. So correlation function, it has to be defined. It has to be defined between two random processes or two random variables. That means correlation function, it becomes irrelevant when you define for a single random variable or single random when it becomes irrelevant when you try to define it for a single random variable. Now mathematically the definition of this correlation function is equal to mathematical expectation of a random variable 1 and random variable 2. So this is the mathematical definition of correlation function. Now if quantitatively, this is quantitative definition. Quantitatively you define this like this. Now qualitatively it can be defined as like this. Qualitatively, correlation function, it gives us the similarity between the shapes of random process 1 and random process 2. So you can say random process 1, we have a random process 2. You try to find it, the shapes of these two random processes, then try to find the similarity between shapes of two random processes. Now similarity, that means qualitatively it can be defined as similarity between the shapes of two random processes. Now try to see if you have two random variables. If you have two random variables coming from the same random process, then the correlation function is called as autocorrelation function. If you have two random variables coming from the different random process, then that's called as cross correlation. So I will try to define autocorrelation function. Autocorrelation function is nothing but the expectation of product of a random process 1, but taken at time interval t, taken at time interval something t plus tau, means taken at time interval different time intervals, or you can say this is nothing but expectation of xt1 and xt2. That means autocorrelation function is nothing but your expectation of the product of random process x taken at t1 and t2 time intervals, like I have defined here. If both the random variables rv1 and rv2 comes from the same random process, stationary, obviously random process has to be stationary here, at time intervals t1 and t2, then the correlation function is defined as autocorrelation function, like I have defined here, this one. So this is your autocorrelation function. Now I will try to define here, if the two random variables rv1 and rv2 comes from the two different stationary random processes xt1 and t1 and y t2 over the ensemble x and y, then the correlation function is called as cross correlation function. So I will define, if I will take random variable rv1 and random variable rv2, they are taken from different random process rb1 and rb2, then this correlation function is called as cross correlation function, and is defined mathematically as expectation of x t1 and y t2. That means cross correlation function, you are trying to find the expectation of product of x t1 and y t2. That means x t and y t, this is random process 1 and this is random process 2. So in nutshell, what you can say that you have correlation function, then you have its two parts, autocorrelation function and cross correlation function. Here you are trying to find the expectation of random variables rv1 and rv2 taken from the same random process. Here you are trying to find the expectation of product of two random variables rv1 and rv2 taken from different random processes. Hope you people have understood what do you mean by correlation function, what do you mean by autocorrelation function and cross correlation function. Thank you.